everyone, so glad you could join me once again. And grade 11s, although if you are in grade 12, this is also useful information. We are going to be looking at financial maths. So we're going to be looking at some of the questions that you would have practiced and maybe had some issues with, and hopefully clear up those issues today. So we're going to look straight at some of the questions involving the use of a timeline, because remember, one of the key things that you learn in grade 11 is how to use a timeline to help you simplify financial maths questions. All right, so the first question says, 75,000 Rand is invested in the bond market. Now, some of you might be saying, but what is a bond market? A bond market is really where government-issued securities are traded. So the government asks the public to lend them money. So it's considered a relatively safe investment vehicle because you are lending money to the government, so your money should be quite safe. But it's certainly not only the government, but huge institutions that trade in the bond market. So we call this trading in bonds, all right? And it's considered a relatively safe investment where you then charge, we're talking about the government, you charge them interest for borrowing your money. Okay, so the bond market is just a market where securities are traded, and generally we're talking about debt that is traded in that market. All right, so 75,000 Rand is invested in the bond market for 9 years. So 75,000 Rand, straight away we can mark down information. That's the value of P. For 9 years, we're not going to say what the value of N is yet, because if compounding changes, then that's going to change our value of N, because we've got to multiply by M. And we carry on reading, we see that in fact compounding does change. They say the interest rate for the first 3 years is 8.5% compounded annually, so only for the first 3 years, which means something else is going to happen. For the next 4 years, the interest rate is increased to 9.75% compounded quarterly. And then, during the final 2 years, the interest rate is 10.25% compounded monthly. So we start off with an annual rate, we then change to compounded quarterly, and then in the last 2 years, it's compounded monthly. Obviously, your interest rate keeps increasing. They say calculate the total value of the investment at the end of 9 years. So to do it, let's put the information they've given us onto a timeline. So we're starting now at time 0, and we're investing 75,000 Rand. There's no further withdrawals and no further deposits. This goes on for a period of 9 years. Now remember, be consistent. If we're going to say these are years, then each interval needs to represent years. We cannot say 9 years and then start working in months. So we've got time 1, 2, 3, and we write down all the way to time 9. There's different things happening. So the first 3 years, we see that our interest rate is 8.5% compounded annually. So for the first 3 years, we've got compounding annually. So here we've got 0.085. And then for the next 4 years, the interest rate is increased to 9.75% compounded quarterly. So for there, we've got 0.0975, and we're going to divide that by 4 to show that our compounding is now quarterly. And then for the last 2 years, 10.2, 0.1025, and this is monthly. So we're going to divide our interest by 12. But by separating the timeline like this, it also shows me that not only should I be dividing by 4 and multiplying by 12 when those interest rate changes happen, I'll also need to change the value of N in my formula. So remember your compound interest formula, A is equal to P times 1 plus I to the power of N. If I'm dividing I by 4, then I need to multiply N by 4. If I'm dividing I by 12, then I need to multiply N by 12. Okay, so that's what we need to keep in mind as we answer this question and find out what the accumulated amount is. So I've got it all nicely set up for us on a nice neat timeline. Just going over again, you can see in different colors we've marked out what's happening at the different points in time, and we can then see how we can move through the timeline using the different interest rates. All right. So what I do is I do the whole sum in one. So in other words, I do it all in one line. Guys, you don't have to do it this way. This is just my method. It's the way I prefer to do it. What you could do is you could break it up into each period, and you could actually work out the amounts at the end of each period and then move those amounts forward. You certainly can do that. What you've got to be careful of, if you're doing that, where you're finding the value at the end of 3 years, then at the end of 7 years, and then at the end of 9 years, what you've got to be careful of is to store that information in your memory each time of your calculator, not your own memory, but the memory of your calculator. Keep those amounts in the calculator, because if you don't use to the exact last digit what was on the calculator, you will then result in a loss of information, and you'll get the wrong, you'll be out by a few decimal points at the end. Okay, so you'll get the wrong cents value a lot of the time if you don't use the memory on your calculator. So how do I do the sum all in one? Well, I say, well, let's represent what's happening at the different points in time. I start off with 75,000 Rand, and then for 3 years, I've got an interest rate of 8.5% compounded annually. So I move to time 3 on my timeline, and then I see at that point, okay, well, for the next 4 years, I see that the interest rate is 9.75% compounded quarterly. So I then multiply by 1 plus 0.0975 divided by 4. So basically my compound interest formula, raised to the power of 16. Why 16? Well, if we're going from time 3 to time 7, that is 4 years, and I need to multiply, not 4 years, that's 4 periods, so I need to multiply by 4 to show those 4 periods, to show that the compounding is quarterly. So we go from time 3 to time 7, so we're going to say 4 years times M, which is 4, and that gives me 16 compounding periods. Okay, so it's 16 compounding periods, not 4 years. All right, so therefore, we raise to the power of 16, and then when I get to that point, so that takes me to point times 7, I then need to move from time 7 to time 9 by multiplying by 10.25% compounded monthly. So I take my interest rate, divide it by 12, but at the same time, I know from time 7 to time 9 is 2 years, but in terms of compounding periods, it's not 2 years, it's 24 months to reflect that compounding is monthly. So you certainly can put all of this into your calculator. It's one long sum, and you'll end up with 172,000 Rand, 721 and 46 cents. All right, guys. So you can see how useful this timeline is in helping us plot the things that are happening with the changing interest rate. And we saw when we looked at the summary of this lesson how it also helped us when we were putting money into the account and taking money out. So to move from one point in the timeline to the next point in the timeline, remember that you've got to use the correct interest rate. That's the key thing that we should remember when we're doing this question. All right. Okay, I think at this point, let's take a quick break. When we come back, we'll have a look at another question. Hello everyone, welcome back. We're to today's session where we are looking at financial maths questions, and we're going through some of the questions that you may have had issues with when you were practicing for yourself at home. All right, so we're going to start with question 2 now, which is all about Lucky Lesego. Why is she lucky? Well, because her mum buys her a new car. And this car costs 200,000 Rand for her 18th birthday. Wow. The car depreciates in value, though, at a rate of 10% per annum using reducing balance depreciation. So let's break a few things down here. When you buy a car or any asset, as soon as you start using that asset, it starts losing value. So straight away, as soon as Lesejo's mum or she drives this car out of the car dealership, that car is worth less than 200,000 Rand, okay? And because assets depreciate, we need to write them off, especially if we're talking about businesses. They often in their accounting need to write off the value of assets. Remember, the asset doesn't reduce all the way down to zero though. It reduces to what we call a scrap value, which is what you can sell it for, the bits and pieces you can sell it off for at the end of its lifetime, okay? So we know that we're talking about reducing balance depreciation, which is the same as compound decrease. So we use the formula A is equal to P times 1 minus I to the power of n. The minus there tells us that we're looking at compound decrease. So this car started out at 200,000 Rand. So that tells me that my value of P is 200,000. Okay, now on her 18th birthday, this is when the mum buys the car. The question says, how much will the car be worth on Lesejo. Lesejo's name changed halfway through the question. How much will the car be worth on Lesejo's 21st birthday? So we're going from the 18th birthday to the 21st birthday. How many years is that? It is, of course, 3 years. All right. They tell us that the depreciation rate is 10% per annum. So I is 0,01. How do I get that? 10 divided by 100. And of course, we're looking for A. So they want to find out what is the value of this car on Lesejo's 21st birthday. So over 3 years, what will the value be? So it's just a simple matter of substituting straight into our reducing balance formula. So we substitute P is 200,000. Of course, we put in our depreciation rate, and N is 3. And then it's just simply a matter of substituting all of those values in your calculator and then working out what the value of Lesejo's car is at the end of 3 years. So if you do that, you should end up with 145,800. 185,800 Rand is the value of this car at the end of 3 years. Now, if you think about it, that's quite a lot of depreciation for 3 years. Maybe in the grand scheme of things, not that much. It's It's over 50,000 Rand. So if it reduces that much in 3 years, certainly by the end of the lifetime of this car, it will be worth very, very little. So let's look at what the next question says. It says, calculate the amount of depreciation each year. Now remember, we are talking about reducing balance depreciation. And what that means is that the amount of depreciation keeps reducing. So therefore, in the first year, maybe the depreciation was, let's say, for example, 20,000 Rand. In the next year, it's going to be less than 20,000 Rand. And in the following year, it's going to be less than whatever it was in the previous year. So that is why we call it reducing balance. Okay. So how do we work out the decrease each and every year? So remember, we said that in 3 years' time, the car will be 145,800 Rand. That's what it's going to be worth. So in total, that value has decreased by 54,200 Rand. So to work out the depreciation at the end of the first year, all we do is we take the depreciation rate and we multiply it by the value of the car at the initial point of time. So 10% of 200,000 would give me the value of depreciation. So if we're looking at the formula, we've got P times 1 minus I to the n. All I'm doing is I'm timesing P by I to see what the value of this depreciation is going to be at the end of the first year. So I say 200,000 times 10%, and that gives me 20,000 Rand. So remember now what's happened is when we get to the end of the first year, the car is going to be worth 20,000 Rand less than it was when she bought it. So what will it be worth then? We started off with 200,000. We've taken away its value by 20,000 Rand. We've reduced its value by 20,000 Rand. So therefore, the car is now worth, at the end of year one, what will it be worth? Well, it's going to be 200,000 minus that depreciation amount of 20,000, which gives us 180,000. So now, in the next year, the depreciation is going to change. In fact, it's going to reduce. How do we know that? Well, firstly, because it's called reducing balance depreciation, but also because we're finding the depreciation on a smaller amount. So instead of finding 10% of 200,000 Rand, we're now finding 10% of the new value. So we're now finding 10% of the new value of 180,000 Rand. So we say 0.1 times 180,000, and that gives us 18,000 Rand. So at the end of year two, the depreciation is 18,000 Rand. And can you see this reducing effect that we're talking about? In the first year, our depreciation was 20,000. In the second year, the depreciation is 18,000. So in fact, the depreciation has reduced itself by 2,000 Rand because it's now based on the lower value of the car. Before we can find what the depreciation is at the end of the third year, we need to take away the 18,000 Rand from the value of the car at that point in time. So 180,000 at the end of the second year minus 18,000 Rand will give me a value of 162,000. So that 162,000 Rand is what this car is worth at the end of the second year. Now, when you're trying to find your depreciation for the third year, what do? You find 10%, not of 200,000, you find 10% of the new reduced value. So you find 10% of 162,000 Rand. So at the end of the third year, we say 10% times by 162,000 Rand, and we see that that is 16,200 Rand. So therefore, once again, you can see this reducing effect on the depreciation amount. This 16,200 Rand of depreciation is less than the previous year's depreciation of 18,000. And that 18,000 was less than the previous year's depreciation of 20,000. Now guys, when you add all of these values together, so when you add 20,000, 18,000 and 16,200 Rand altogether, what do you think that amount will be? Well, we're talking about depreciation over 3 years, and we saw that Linda's car, or Lisa Lesejo's car, we keep changing her name, we see that in 3 years' time, Lesejo's car was going to be 145,800. It had reduced in value by 54,200 Rand from its original amount of 200,000. So therefore, all of these depreciation amounts, if I add them up, 20,000, and you can do this as a quick check, plus 18,000 plus 16,200. If you add those over 3 years, that was the rates of depreciation, it should be equal to the total depreciation for that time, which was 54,200 Rand. All right. So that is how, or what we can sort of break this reducing balance down into. And I wanted to show you this example so that you can understand why we call this reducing balance depreciation. Because each year, the value of your depreciation is reduced. So therefore, you can see that each year, this car is depreciating by a smaller and smaller amount and when you add them all together, it will give you the total amount of depreciation over that entire 3-year period. All right, guys. So this is a very important concept because many of the questions that you do will be based on reducing balance depreciation and not on simple depreciation. Now, simple, and let's touch on it quickly, we can see that in reducing balance depreciation, the depreciation amount decreases each year as the value of the car decreases. However, in simple depreciation, where we have A is equal to P times 1 minus I times N, so it's not to the power of N, each year, so if we're doing the exact same question but using straight line depreciation, each year your value of depreciation stays exactly the same. So if we had a car that was 200,000 Rand and it was 10% per annum on straight line depreciation, each year over 3 years, your depreciation amount will be what? It would be 20,000 Rand each and every year. So at the end of time one, it would be that. At the end of time 2, it's going to be the same calculation. And at the end of year 3, once again, 20,000 Rand. So what do we see in straight line depreciation? If we added 20, 20, 20, we get 60,000 Rand. So it results in a lower value of the car at the end of the time period. So you can see if we compare straight line depreciation to reducing balance depreciation, we see that in reducing balance depreciation, the car overall will reduce or depreciate by a smaller amount because, important concept, I've said it over and over again, because the depreciation amount decreases each year as the value of the car decreases. Okay, so therefore you can see that at the end of the day you'll end up with a better value for your scrap value than you would if you were doing straight line depreciation. All right, guys, that is all we have time for. Thank you so much for joining me once again. Have a great time. Until next time. Cheers.